Hello friends, welcome back to another random Saturday video. I haven't been feeling great today, so usually when that happens, mentally, I like to come down to the shop and just tinker with something. And back when I did the video for the soundboard, I thought a good topic for the show would be to do a little soldering tutorial. And I bought some of these little kits that are solder your own little D6 electronic D6 roller, dice rolling kits. And I thought this would be a fun project to solder. And then I bought extras as giveaways. And I never found out a way to figured out a way to put it into the show. So we're just going to do it here, and then maybe we'll give some kits away. So if you're interested in putting together a little D6 LED dice, stick around, watch the video. I'll show you how I'm going to do it, and then maybe you can win one of these. This kit doesn't come with much in the way of instructions, but we have all the parts laid out here. So the first thing I'm going to do is kind of sort through this mess of components and figure out what everything is so that I can just solder it all together. Okay, I have everything sorted here, and it's very important that you know the values of the individual resistors so that you don't mess up when you put them on your board. So there's a few different ways you can do that. If you are smart, you can look at these. There's little bands of color, and I know it's probably not coming across very well on the camera. Little bands of color on the resistor. So you have essentially 3 bands that tell you the resistance and 1 band that tells you the tolerance, like plus minus 5% or whatever it might be. And so you can plug those into a calculator. It's just basically this color multiplied by this color multiplied by this color and then a tolerance, blah, blah, blah. Or you can just take your digital multimeter and read them to make sure that you've got them sorted properly. The instructions don't really tell you anything about the colors. It just tells you how many of each and what their resistance is, or in the case of a capacitor, what their capacitance is, that sort of thing. We have 2 different transistors that we have to keep track of. We have 2 8550s, 3 8050s, so we don't want to get those mixed up. LEDs, of course, are all interchangeable, so the rest of this is pretty straightforward. We're just going to start soldering. I'm going to start by putting the IC sockets on. This is essentially just warm-up, so I'm not messing with a component that I could accidentally fry. This will help me get a feel for the soldering iron and the solder, and then I'll move on to soldering on actual components. A couple of these pins in this socket were really badly damaged, and that's okay. It's easy to kind of pop them out of the socket and get them pressed back down in, but you have to be very careful when you go to solder this and make sure that your pins are all fully seated. Because they're so easy to pop out, while pressing this through the board, you could accidentally unseat them. Helping hands are not a requirement, they just make life way easier. If you're having trouble getting the solder to flow or getting the pen heated, having a little dab of solder on your soldering iron while you press is a really good way to get heat to transfer faster. More thermally efficient, let's put it that way. Looks like we have 2 pens on this chip that aren't being used. I'm just checking adhesion. You can kind of tell. It's going to be difficult for me to demonstrate this to you through the camera, but once the solder pulls and it actually flows, it'll form kind of the bottom or the top tip of a Hershey's Kiss on the pen. Let's see if I can get you a picture. It's real hard to see, but the top of the pen where it attaches to the board, it'll form kind of a Hershey Kiss shape, and that's how you know you have good adhesion. You shouldn't, and it should kind of flow all the way around the pen on its own. You shouldn't have to coerce the solder around the pen. Once you've got good contact adhesion, it'll just kind of flow around the pen for you. I got one pin here I don't like. And you shouldn't have to force it. Okay, when you're putting on surface mount components, you could clip these leads before putting them in. And it makes the soldering job a little bit easier because you're not dealing with these long tails sticking out. But when it comes to dealing with LEDs, you have to be very careful about how you put these in. This is a diode, and a diode, think of a diode like a one-way street. Electricity can go through it one way, but not back the other. And so when you put them on the board, you have to be very careful about the orientation of them. Now, our board here has this little diagram of a diode, and it shows us which side is the anode and which side is the cathode, or positive and negative. But it doesn't tell us which one. If you don't know what you're looking at, you have no idea. So it appears like there would be a flat spot, and on some, like a transistor, for instance, it does in fact have a flat spot. You're not going to be able to see that. I understand that. But on these circular LEDs, there is no flat spot telling us which side is the cathode. If you look at your board, this little arrow here and this flat spot is the cathode side, or the negative side. So an easy way to know on an LED, like a surface mount LED, which is the anode and which is the cathode, the long tail is the anode. So when we put these in, we want the short tail, we want that arrow pointing at the short tail, just like this. So I'm going to go ahead and put these in and get them soldered. So when you turn this over, before you start soldering, you want to make sure that all of your long tails are on the same side, so you at least have a 50-50 chance of being correct. But trust me, short tail, arrow points towards the short tail. This part's a little tricky. I'm going to flip these over and set them right down on the table with all of my LEDs sticking through the board. And then I'm just going to put a small dab on the anode side of each, just to hold it in place, and then I'll flip the board back over and reposition them how I like, and then I'll go ahead and finish soldering them. Okay, now they're all soldered to the board. I can flip it over. I can see which ones are too high, which ones are too low, which ones are out of whack, and if I need to adjust them, all it takes is I can reheat and adjust, and then they're set. And it just takes a second. Okay, now that they're all sitting the way I like, I'll flip it over and solder the rest. I got all of them mounted now. I'm going to go in with a set of cutters and cut off all these tails. You can leave them until you're done with the project if you're not comfortable and you think you need to pull these out and put them back in. But they're in the way of getting my soldering iron into the other resistors, so I like to just clip stuff as I go. Okay, next I'm going to do the resistors that are here in between my LEDs. I've got 3 470s and a 1K. If you are uncomfortable with resistors that are really close to LEDs or whatever, you can mount these on the bottom side. And so, for instance, if you were going to use this panel, say you were going to put this in an enclosure and have these sticking out, you might want to bottom mount these resistors just to give yourself a little more working room. I am not doing that, so I'm just going to go ahead and put these on the front. Resistors do not have an anode and cathode, so any way you put them in is fine. Alright, that's the right hand side of the board done. I'm going to work my way right to left. So the next thing that's going to go in is these 4 transistors. Now, a transistor is essentially a logic gate. You've got 3 pins. You have an input, an output, and the middle pin is the control. So if the middle pin sees voltage, then it allows electricity to flow. If not, it stops the flow of electricity. It's kind of like a little switch. And these do go in a particular way. If you look at your board, you'll see, let me see, here's an 8550. They are shaped roughly the same as that image is. There's a flat side, so you want to put these in exactly as shown in that image. So I am going to solder the input pin only, and then I can adjust, and then I'll finish solder them. Okay, I have those all glued in basically the way I want them, so I will solder them from the back. Now, transistors are in fact heat sensitive, so you want to be careful when you're soldering on them. You don't want to spend too much time piddling around. You just kind of want to get the solder on and go. And that's why I did all the non-heat sensitive components first, to kind of give myself a fighting chance at hitting these without frying them. The other thing I'm going to do is work my way down and then back. So I'll solder 1 pin on each, then I'll come back, and that gives them a little chance to cool down before I slap the heat right back on it. All right, we've got our LEDs on, our resistors are on for those, our transistors are in place. I'm now going to populate this resistor bank. Alright, if you are as particular as I am, you will have lined all of your colored stripes up, and you'll want your resistors looking very pretty after you're done soldering them. Problem is, you flip this board over and they're all going to start sliding out, and it's not going to look nice. So you could do these one at a time, flip them over. You could do some of the techniques we've already done, soldering 1 pin in, flipping it, holding onto the resistor with your finger while you finish soldering. Or, what I can do, take a piece of heat shrink tubing and a piece of tape. So I'll take a piece of heat shrink tubing, lay it across here, take my tape, run it across all of my components, wrap it around the ends of my board, and now when I flip this over, all of my resistors sit in place and I don't have to worry about them falling out. And as resistors are essentially little electric heaters, you don't have to worry too much about hurting them with the soldering iron. We can take our tape off, and our resistors still looking pretty. All right, what's left? We have a power connector up here. We have another 10K resistor that needs to fit in there. We have our last 8550. And then we have some capacitors that need to go on and a few more little resistors, and then we can test it. So I'm going to go ahead and put this power switch on next. I'm going to continue working my way right to left. Okay, I just confirmed with my voltmeter. If you notice on this circuit board, the holes for the switch are longer in one way than they are the other. And that's because the switch is not a perfect square, it's a rectangle. And so you need to be careful when you put it on that you don't jam it down in there the wrong way, or it's just not going to work. Now I can go 180 degrees either way, it's fine. One more spot up here for a 10K resistor. Okay, we've got our last 8550 transistor here. And since we're doing a transistor this time by itself, I'm going to give it some time to breathe between putting the heat to it. It really isn't something you should be scared of doing. You shouldn't worry too much about frying these transistors. You know, if you're applying the iron to the front side or you're leaving it on there like across all 3 pins the whole time, then yeah, you might do some damage to it. But as long as you are just going in with a soldering iron, touching a pin, giving it a little bit of solder, pulling off, you're probably never going to hurt it. I do say probably though. At the top here we have our power connector. Down here we have our 4.7 mega ohm. So that's this guy. And lastly in this row we have our small button ceramic capacitor. Now there are two types of capacitors. There's these little ceramic capacitors and this, I don't know what it's called, electrolyte capacitor. These little ceramic guys do not have an anode and cathode. You can put them in any way you want. These guys, however, this is a 1UF, does definitely have a anode and cathode. The cathode will be marked with this white stripe, so this is the negative side, and again it has the long tail, just like a LED to tell us that's the anode side. So my little button here, I can put it in either way. I'm going to put it facing out so that if I am ever curious, I can read that it is a 104. Alright, our last three components is our 1UF capacitor and a 10 meg and a 3.3 meg resistor. So I'm going to go ahead and start with the capacitor. You can see on the board here, they've gone ahead and marked the negative side with that white mark. So we line our white stripe up and our long tail will go in the plus hole. And that's how you align these capacitors. Now we just have our two final resistors. Our 10 meg goes here. And our 3.3 meg goes here. If you happen to get one of these kits and you need help figuring out which resistor goes where, drop me a line in my email and I'll help you out. And that is all of our components soldered on. This is not my best work by far. I'm way out of practice on surface mounting, but everything's on there. It's time to put the chips in. I should have noted when I installed these sockets, there is one side of this socket has a little notch cut out in it. It's marked on the board as well as in the wiring diagram to be very careful which side you put these sockets in, because these chips are little computers and the pinout on them is very particular. When you're putting these in the socket, the side with the little, there's a side of this chip that has a little indent on it that looks similar. So I can get it to flash again. It flashes there in the light. That little flash you see there, that goes towards that little cutout. So I'm going to go ahead and put these in. They will go in somewhat firmly. You got to make sure you don't bend the pins and jam them into the wrong hole. It's easy to do. Just kind of go work your way down. I like to put one side in like this, kind of lean it a little bit, and then I can work on the other side with my fingers, especially if the pins are a little bent like these. It helps kind of get them where they're supposed to go. It should not be, there should not be a whole lot of resistance when you push that down in there. It's going to be a firm insertion, but not, you shouldn't have to struggle. All right, last resistor, or last chip goes in, microprocessor, what are you going to call it? I believe this is a timing chip. I don't really know. I'm not that much of an electronics nerd. I just like putting these kits together. It's a fun little weekend project. There we go. Let's plug it in and see what happens. This kit runs off 4.5 to 6 volts. So I've got this old USB cord. USB runs at 5 volts. I'm going to cut into it, see if we can't power this thing with any USB socket. So while USB is a standard, the wiring inside of a particular manufacturer's wires are not. So your mileage may vary, but I'm going to assume that the red and black wires are my power wires and the white and green are data. So we're going to test it, find out. Bingo! We got 5 volts on red and black. We can solder it to our connector and we're ready to go. Green and white, completely unused, getting rid of them. You could do fancy twist joins on these. I am just going to butt join them and hope the solder holds. When you're butt joining wires like this, it's a perfect application for helping hand. There you have it. We should be good. Let's plug her in and see what happens. We either win or we lose.
We have lights.
See what happens.
All lit up. Get some flickering. Dice is rolling. And a 3. Cool little kit. I think I paid maybe $2 for these. If you're interested in soldering kits like this, I will put a link in the description where you can purchase your own. If you would like to win this exact kit, I have 3 available. Just leave a comment in the description below saying that you want a kit, and we will pick a winner next Saturday. That's Saturday the 15th, I believe, and I will send you a kit out, and you can make your own little dice thing. Cool. Thanks for watching.
Daddy needs a new pair of shoes.